Hey everyone, welcome to the channel. In today's video, we're going to explore how to build a flexible overlay system in Angular 20. The kind of overlay that can adapt to different situations in your app. Think of those moments when you need to show a confirmation pop-up, open a custom form in a dialog, or display a quick message without taking users away from the current screen. That's exactly where dynamic overlays shine. Instead of creating a dozen different components or routes, we'll build one system that can handle it all: clean, reusable, and user-friendly. This is a must-have feature for modern web applications, and by the end of this video, you'll know exactly how to implement it in your own projects. So if you're looking to enhance your UI and streamline user interactions, you're in the right place. Before we dive in, if you enjoy content like this and want to stay updated with future tutorials, make sure to hit that subscribe button and turn on the bell so you don't miss the next deep dive on Angular and UI design. Alright, let's jump into the code. But before we begin, here's the final result of what we're building. 2 buttons appear on the screen, and each one opens an overlay with different content. Once, the form is filled and saved, showing that we can easily capture and use the submitted data. So, let's get started. Let me walk you through the setup process for our Angular 20 project. I start by creating a fresh Angular project right from the terminal, called Dynamic Overlay. During setup, I choose zoneless change detection for better performance, and Sass as the styling format. I also disable server-side rendering, since it's not the focus of this tutorial. Once the setup is complete, I open the project in Visual Studio Code to begin working. The first thing I do is generate a component named Dynamic Overlay using the Angular CLI, skipping the test file. Then I remove the generated HTML file because we'll define the template inline inside the TypeScript file later. Next, I create an interface named Dynamic Overlay Config, which will define the shape of the data passed to our overlay. I also add a directive called Component Host to Mark, where we'll dynamically insert components at runtime. This one is also created without a test file. Finally, I generate a service called dynamic-overlay.service. I explicitly add the .service suffix to avoid any conflicts with the component name, something worth noting now that Angular 20 uses simplified file naming by default. And that's it. The base structure is ready. From here, we'll dive into building the dynamic overlay system itself. We start by creating the Dynamic Overlay Config interface, a key part of our overlay system. This interface defines which component should be displayed in the overlay, along with optional input data and a title. It's declared as a generic, meaning we can strongly type the data passed to each overlay instance, keeping things type-safe and predictable. It also uses Angular's type utility, allowing us to dynamically inject any component we need. For simplicity, we're only handling the title in this version, but the interface can be extended later with more options, like custom buttons, sizes, or animation behavior. In the demo, you'll see how this flexible, type-safe structure lets us reuse the same overlay system for different components and contexts, all from one clean configuration. Now that we have the configuration interface, we need a way to tell Angular where to inject the dynamic content. For that, we create a directive called Component Host. Inside it, we inject Angular's view container ref, which gives us access to the exact spot in the DOM where the overlay content should be rendered. The directive is simple but essential. By applying it to a template, we mark it as a target for dynamic components. This is what allows the overlay to be completely flexible, rendering whatever component we define in the config exactly where we want it, and only when needed. With the configuration and directive in place, we now pass everything to the dynamic overlay component we previously created. This component acts as the container for our dynamic content. It includes a strongly typed config input based on the dynamic overlay config interface, so each overlay knows exactly what to render. We also introduce a signal to track whether the overlay is currently open or closed. The class.opened binding in the host dynamically toggles a CSS class based on that signal, allowing us to control the overlay's visibility in a clean, reactive way. With this structure, the overlay is now ready to accept and display components based on the configuration passed in. Next, we define the HTML template for the dynamic overlay component. The structure includes a container with a title section, and a content area. If a title is provided in the config, it's displayed using Angular's if syntax. We also add a close button that will later trigger the overlay's closing logic. In the content section, we place a ng template marked with the app component host directive. This is where dynamic components will be injected at runtime. Back in the class, we connect to this placeholder by using viewChild to get a reference to the directive and its view container. Finally, we stub out two key methods, OpenOverlay and CloseOverlay. For now, they just throw errors as placeholders. We'll implement them shortly to control the overlay's behavior and lifecycle. Now let's take a look at the component's styling. The host selector positions the overlay as a fixed panel on the right side of the screen, with a high Z index to ensure it appears above everything else. It's initially placed off-screen using right -475px, then smoothly slides in when the .opened class is applied, thanks to the CSS transition defined below. The width is set to 450 pixels, with full viewport height. A white background and subtle shadows give the panel a clean, elevated look. The border left provides a soft divider from the main content. Inside the overlay, the dynamic overlay class arranges everything vertically using Flexbox. The title section at the top has a fixed height, a bottom border, and spacing to align the title and close button nicely. The title itself has no margin, and the close button is styled with a smaller width to keep things balanced. Finally, the content section adds padding to ensure consistent spacing around the injected dynamic components. Now let's walk through the implementation of the dynamic overlay service, which manages the full lifecycle of our overlay. It's provided in the root, so we can access it anywhere in the app. We store a reference to the overlay component so we can reuse or destroy it later. The service also injects application ref, which gives us direct access to the application's view layer, something we'll need for dynamic component creation. The OpenOverlay method checks if the overlay component already exists. If it doesn't, we call createOverlayComponent to generate it. Inside that method, the first step is to grab the injector from the application reference. This ensures that any services or dependencies required by the overlay component are properly resolved. Then we create the overlay dynamically using Angular's createComponent function and pass in the environment injector. This gives us a live component ref that represents the overlay in memory, but it's not part of the DOM just yet. So next, we manually attach the component's view to Angular's change detection tree using appref.attachView. To actually display the overlay, we access its root DOM node, which we extract from the host view using embedded view ref.rootNodes. Finally, we append that DOM node to the root of the application, either under approot or directly into the body. This gives us a fully functioning, programmatically attached overlay that behaves like any other Angular component, but exists independently of routes or templates. The service also includes CloseOverlay to hide the overlay and DestroyOverlay to clean up both the view and the DOM when it's no longer needed. Altogether, this pattern gives us precise control over when overlays appear, what they show, and how they're removed, all from one centralized service. Now that the service is fully wired to manage the overlay's lifecycle, we can complete the functionality inside the dynamic overlay component itself. We start by implementing the OpenOverlay method. First, we store the incoming configuration, which includes the component type to render and any input data. Then we access the view container ref through our component host directive. This gives us a precise placeholder in the DOM where we want the dynamic component to appear. We clear any previously rendered components to make sure we start fresh each time. Then we dynamically create the component specified in the config using createComponent. If the config also includes data, we loop through each key and assign the values to the newly created component's inputs using setInput, ensuring the component is properly initialized. Finally, we mark the overlay as open by setting the reactive signal to true and return the component reference so the caller can interact with it if needed. For CloseOverlay, the process is reversed. We toggle the open signal to false, which triggers any visual transitions in the template. Then we use a small timeout to allow the closing animation to finish before calling the DestroyOverlay method from the service, which fully removes the overlay from the DOM and memory. This gives us a clean, reactive, and highly reusable pattern for dynamically rendering content in an overlay, with full control over setup and teardown. With the overlay system ready to render dynamic content, the next step is to create a few components that will display inside it. In this case, we generate two simple form components, Form1 and Form2. These components will act as content examples, allowing us to demonstrate how the overlay adapts to different inputs and behaviors. We generate each one using the Angular CLI and use the skip tests option to keep the structure clean and focused. Once created, these forms can define their own template, logic, and output events, and we'll pass them into the overlay using the configuration system we set up earlier. This approach proves the flexibility of our overlay, showing that it can render completely different UIs while reusing the exact same container. It also prepares us to handle form submission, loading states, and input binding, all without needing to rewrite the overlay logic itself. Now let's implement the first example form, Form1, which will render dynamically inside our overlay. First, in the component metadata, we import Common Module and Forms Module. Common Module gives us access to built-in Angular directives, while Forms Module enables the use of ngModel, which we rely on for two-way binding of form inputs. In the template, we start with an @if block to conditionally render a loading spinner. This uses the loading input, a Boolean passed in from the parent, to determine whether the form should show a visual indicator of background activity. The spinner itself is just an image, but the visual feedback it provides helps users understand that an action is in progress. Below that is the main form. It's wrapped in a container for styling purposes and includes two key input groups. The first group consists of a labeled email field, bound to user.email using ngModel. This two-way binding ensures that as the user types into the field, the user object is updated in real time. The second group is a checkbox, labeled Enable Newsletter, also using ngModel, this time to bind to user.enableNewsletter. This means we have a unified user object with all the form values, easy to handle and emit when needed. Below the fields, we have two buttons placed inside a container that aligns them to the right. The cancel button triggers the cancel method, which calls the dynamic overlay service to close the overlay. The save button calls save, which emits the current user object using the @output event emitter. This lets the parent component, the one that opened the overlay, respond to the form submission and handle the data. In the class, we define the @input property loading to control the spinner from outside, and the @output property save event to notify when the form is submitted. The overlay service is injected directly using Angular's inject function, which keeps the constructor clean and the dependency clearly defined. The user object is initialized with default values, an empty string for the email and false for the checkbox. So the form starts with a known, valid state. Now let's talk about styling. The spinner uses absolute positioning to center it both horizontally and vertically within the form. It also includes a rotate keyframe animation to make it spin smoothly, adding a bit of polish to the loading state. The form layout uses Flexbox to space out the fields nicely. Each form group is stacked vertically, with appropriate margins. For the checkbox, we override the default direction to make the checkbox and label appear side by side. We also add margin between the box and its label for better readability. Input fields are styled with padding, border radius, and a subtle border to match a modern UI look. Lastly, the buttons are styled for clarity. The Save button uses a bold blue background and white text to draw attention, while the Cancel button is white with a colored border and blue text, giving it a clear but less prominent role. Altogether, this component is clean, reactive, and self-contained, and it works perfectly with the overlay system we've set up. Now that we've seen how Form1 works, let's move on to Form2, which provides another example of dynamic content to inject into the overlay, this time using a slightly more detailed form. Just like before, we start by importing Common Module and Forms Module in the component metadata. At the top of the template, we check for the loading input using an if block. If loading is true, we show a spinner image to indicate background processing, for example, during data submission or validation. Below that, we define the form using a container div to group our input fields. The first field collects the user's first name, using a text input bound to user first name via ngModel. The second field captures the last name, also a text input with two-way binding to user last name. The third input is for the user's age. This time, we use an input of type number, bound to user.age, and we add a minute value of 0 to ensure only valid positive values are accepted. These three inputs are bound to a shared user object in the class, keeping all form data in one structured model. After the fields, we include a button container with cancel and save buttons. The cancel button calls a method that closes the overlay, using the same service we injected in Form 1. The save button emits the current state of the user object through the save event output, allowing the parent to capture and process the data. In the class, we define loading as an input so the parent can show or hide the spinner, and save event as an output to emit the submitted user data. We injected the dynamic overlay service directly using Angular's inject function, which gives us a clean way to call close overlay when needed. Finally, we initialize the user object with empty values for first and last name, and null for the age, so the form starts in a clean, unfilled state. Just like Form 1, this component is fully self-contained, reactive, and designed to be injected into the overlay system without any structural changes to the container. This approach makes it easy to reuse the same overlay component while rendering entirely different forms, each with their own logic, inputs, and outputs. For Form 2 styling, we're applying the exact same structure used in Form 1. That means we reuse the layout classes, spacing, and button styles, ensuring consistency across both forms. This avoids duplication and keeps the visual experience unified, especially since both forms are rendered inside the same overlay. If needed, we can always extend or override specific styles later, but for now, the shared styling keeps things simple. Now that both Form 1 and Form 2 are implemented, we move on to the app component, which acts as the entry point for triggering our dynamic overlays. In the component decorator, we keep things simple. The HTML template includes two buttons, one to open Form 1 and one for Form 2. Each button is bound to its respective method, Open Overlay with Form 1 and Open Overlay with Form 2. These buttons are placed in the center of the screen, thanks to a few utility styles we'll cover in a moment. In the class, we start by injecting our dynamic overlay service, which we'll use to open and close overlays. We also define two flags, Form 1 loading and Form 2 loading. These control whether the spinner should appear inside each form, and they're passed through the overlay config. When Open Overlay with Form 1 is called, we invoke the overlay service's Open Overlay method and pass a configuration object. This includes a title, the component to render, in this case, Form 1, and a data object with the loading flag. The method returns a reference to the dynamically created component, which we use to subscribe to its save event. When the user submits the form, we log the result to the console, then simulate a 3-second loading state using RxJS's timer function. During this time, we set the form's loading input to true. Once the timer completes, we turn off the loading spinner and close the overlay. The Open Overlay with Form 2 method works exactly the same way. The only difference is the component being injected. This time, it's Form 2, along with its own loading flag. This setup shows how powerful and flexible the system is. We can inject any component with its own data and behavior and still manage it using one unified overlay system. Now let's take a quick look at the styling. In the SCSS file, we use the host selector to center the content both vertically and horizontally on the screen. The container is displayed as a flex column, with spacing between the buttons and some top margin to visually balance the layout. Each button is styled with consistent padding, rounded corners, bold white text, and a bright blue background, matching the look and feel of our overlay forms. The result is a clean and interactive UI, with two clear actions that let the user experience how different forms can be rendered and managed dynamically. With everything set up, it's time to launch the app and test how the dynamic overlay system works in action. As soon as we run the project, we spot a quick issue in Form 1. The closing div tag is missing. This breaks the layout structure slightly, and now the template compiles cleanly. But on running the app again, we hit a runtime error, cannot read properties of undefined reading view container ref. This points us to the dynamic overlay component, where we're trying to access component host, but we forgot to import the directive into the components module. Once we add component host to the imports array, everything works as expected. The overlay opens, the correct form is displayed, and save/cancel behavior works smoothly. As a final touch, we add a proper close icon for the overlay and a spinner icon for loading feedback. And before we wrap up, you may have noticed some AI-assisted code suggestions appearing while we worked. Tools like GitHub Copilot can be extremely helpful, especially for boilerplate or repetitive tasks. But keep in mind, they're not always correct. As developers, it's important to understand and control our code, not just accept suggestions blindly. The more we master the framework, the more confident we are in shaping clean, scalable solutions. Thanks so much for watching. I hope this tutorial helped you understand how to build a flexible dynamic overlay system in Angular 20. If you found this useful, don't forget to like the video, subscribe to the channel, and hit the bell so you don't miss future content. See you in the next one.